Hello, guys. Well, today we're going to talk about some process that we have to control. Okay, this is going to be the process control. But first of all, we have to define what type of process we're going to control. In this case, remember that we have three types um, of transfers. The first is heat, mass, and momentum. Well, as we already know, we already checked and we already viewed in the previous quarters, we're going to work with the heat, the mass, and the momentum. But when we're talking about heat, it refers to all the things that are that they involve heat transfer. Okay, remember that the transfer can be the radiation, mm, convection, and conduction. Okay, we have three types of transfer. In this one, we define the transfer as a flux. The flux that we're going to be working with is the letter Q. In this case, is relating what's going to happen when I transfer temperature in a certain distance. This is ruled by a Fourier-Selmal conductivity law. And the driving force that we have is a conductivity and a temperature. The important part in here, the conductivity is going to be the same, depending on the material, of course, but it's going to be constant. That's the difference between the temperature. The temperature is going to be different. So according to this, we're going to have Q that it refers to the transfer of energy and the temperature. This letter H is referring to the convection. Okay, remember that we have the conduction and convection. Also, we have the mass transfer. The mass transfer is when I have the diffusion coefficients. This one is given by a concentration and a certain distance. Remember that is passing an object, a particle to another object, and we're tending to the equilibrium. This one is referred as a distance. This one is given by the fixed diffusivity. This one, the important part is the diffusion coefficient, and we have the concentration. This one, I have the first value that it's the concentration, the different concentration. And the last one is the one that we talk about momentum. This one will refer to the shear rate, and the stress. We're referring to different things. Remember that through a pipe is passing a liquid, but the stress that we're going to have is given by the pipe. So according to this, I care about the radius that it has. Okay? According to this, first thing that we have to learn is that this one is given by Newton. Okay? The Newton behavior of liquids. This one is going to help me defining the density, the viscosity. We have to define all of them. What for? Well, we care about these details because we're going to start talking about control process. If I have heat process, I have to consider that I need to control everything. I need, first of all, an instrument that helps me to control the temperature. Okay? If I go with the mass, I need to determine the concentration, and the last one, I needed to determine the density and the viscosity. All of them, they have a specific thing that we're going to control. To start this, also you have to learn that each of them have a specific equation, that they have a balance situation. If I go with the heat consideration, I need to consider the external heat, I need to consider the internal heat, I need to consider the energies, all the energies that they have. Also, if I go with the mass, I need to consider what's the mass in one part and what's the concentration in the other one. According to this, I will be able to create a balance. And the momentum, I have to consider all the forces that are given in the system. Why we care about this? Well, because first of all, in the control process, we have to define what things are important. In this case, first we're going to start with the thermal situation, with the heat consideration. So, to consider the heat conduction or convection, we need to care about what? Important thing about the heat transfer is that I need temperature. Also, I need the materials that they are made and the distance that they have. Also, why we care about this? Because each of them we're going to control each part. But remember that we have to define if we can control or if we can't control. For example, the temperature is possible to control? Yes, okay, because we can increase or decrease. But the materials we have to change before the process starts, we have to change. But when the process is working, it's impossible to change it. Okay, so that's why you have to define which variables are going to be able to be controlled and which ones are not going to be able to be controlled. Also, the distance that they are going to pass through. According to this, we're going to determine also equations. The equations that are going to be principal and are going to be important to have. The first one, the control that we have, we're going to talk about the heat transfer. We have to remind that when we talk about the heat transfer, we have the first one that is the internal, the kinetic, and the potential energy. We have these situations. We have the internal, the kinetic, and the potential energy. Also, we have to think of what's going on in here. These are my principal considerations. If I consider all of this, we're going to determine the first thing. The first thing is going to be a balance. The internal, all the energies that is entering, internal, potential, and kinetic, in the input, minus what happens? The same situation, all the energies, all the energy, in this case internal, potential, and kinetic, in the output. Okay? We're creating a balance because we're going to do an exercise in which you're going to consider what thing is important to consider, what thing is not, and you're going to determine the equations. Also, we're going to have the heat that we're going to add, okay? In this case, could be radiation, convection, or conduction. You're going to add the heat. According to this, is going to be added. So that's why we have the plus. Also, the things that you're losing, okay? You're going to consider all the things that are around it. In this case, if we are talking about the work done by the system, this one is telling us what happens. It's telling that the energy is living, in different situations. How? Maybe in a pipe, the energy that it's going to the output, well, to the external part. Okay, so that's why you have to consider all the things that are living. And in this case, it's going to give us the time the exchange rate. That's one when we consider the thermal. When we consider the momentum, when we consider the momentum, we're going to have it easier. Why? Because we're going to talk about the flow into the system. We're going to have the flow out of the system. Also, this one is important. Well, we're going to consider this momentum. Also, it's possible to consider as a mass transfer. Why? Because in this one, we consider also the chemical reactions. And this one is going to give us the time rate. Remember that when we have these situations, we have to define if they have interaction between all the components. It's not the same if I pass water as if I pass one chemical that is going to react with another one, okay? Because that one is going to give us energy, is going to change the amount of moles that we have in each part. So that's why we're going to consider as a different part, okay? That's why we're considering as a momentum or mass transfer. In this case, the momentum is moving, that's why we have the flow. But if we consider the mass, we're going to have the chemical reaction and it's going to change the consideration. Why we care about this? Well, we care about this in one simple detail. Because if we have, for example, a system, that it's centering one mass and it's leaving one mass, but we have a heat consideration in it, we have to consider everything. Remember that when we were working with the unitary operations, we checked some of these details. Well, they are important because we're going to have one consideration. We're going to have the consideration of all the variables and all the equations. Okay, we're not going to solve it. We're going to propose how we can solve it. That's a big difference. Okay? In the next video, we're going to check one exercise to solve these details. Okay?